are in chapter 4.1 and we're going to be solving systems of linear equations by graphing. Our first objective is to decide whether an ordered pair is a solution of a linear system. So equations in the form ax plus by equals c are lines when graphed. Two such equations together form a system of linear equations. A solution of the system is an ordered pair that satisfies both equations. Recall that an ordered pair is x comma y. And when it says satisfies both equations, that means when you take the x coordinate and plug it in for x, and then you take the y coordinate and plug it in for y, you will end up with the left side equaling the right side. And here they have an example. They say the ordered pair 2 comma 1 satisfies this system. So we can check it by taking x, which is 2, and y, which is 1, and plugging it in to each equation one at a time. So let's see, 3 times 2 plus 2 times 1, and we want to know, does this equal 8? So 3 times 2 is 6. 6 plus 2, well, that's 8. So 8 equals 8, and it works out. Now we would check it in the second equation, and we have 4 times 2 minus 3 times 1, and we want to know, does this equal 5? So 4 times 8, or 4 times 2 is 8, minus 3 times 1 is 3. 8 minus 3 is 5, so it works. Therefore, this ordered pair 2 comma 1 is a solution to this system. Now let's go in our books to page 285 and let's look at problems 2 as well as 6. And the instructions say determine whether the given ordered pair is a solution of the system. And for number 2, they have the ordered pair -2, comma -5. And the system is 6x minus 2y equals -2. And 3x plus y equals -11. And just like before, we're going to take the x coordinate and plug it in for x, and the y coordinate and plug it in for y. We're going to do it for both equations, and we'll see if the left side equals the right side. So we have 6 times -2 minus 2 times -5, and we want to know, does this equal -2? So 6 times -2 is -12. -2 times -5 is 10. And then -12 plus 10, that is -2. So it works for the first equation. Now we're going to check it for the second. And again, we'll have 3 times -2 plus -5. And we want to know, does this equal -11? So 3 times -2 is -6 plus -5. -6 plus -5 is -11. Therefore, it works, so we will say yes. The ordered pair -2, comma -5 is a solution. All right, let's move on and do number 6. So this time the ordered pair is 10, comma 7. And the system is 6x minus 5y equals 25. And 4x plus 15y equals 13. And now we're going to check to see if the ordered pair is the solution. So x is 10 and y is 7. So we're going to start the first equation, and we're going to have 6 times 10 minus 5 times 7. And we want to know, does this equal 25? So 6 times 10 is 60, minus 5 times 7 is 35. Well, 60 minus 35 is 25, so it works for the first equation. Now let's move on to the second. So we have 4 times 10 plus 15 times 7. And we want to know, does this equal 13? Well, 4 times 10 is 40, plus 15 times 7 is 105. Well, 40 plus 105 is 145, which is not equal to 13. So it fails in the second equation. Therefore, we will say no, the ordered pair 10, 7 is not a solution. Let's move on to objective 2, and we're going to be solving systems of linear equations by graphing. There are 4 steps. Step 1, start by graphing the first equation. Then step 2, graph the second equation in the same coordinate plane. Step 3, if the lines intersect, the point of where they intersect is a solution. And then for step 4, whatever the point was in step 3, you're going to plug it into both equations to make sure the left side equal the right side. Alright, let's go in our books to page 285, and let's start by looking at number 16. The instructions say solve each system by graphing. And in 16, the system is x plus 2y equals 2, and then x minus y equals 2. Now recall the ways, or the number of ways that you can actually graph a line. Since both equations are in the form ax plus by equals c, we're going to graph them using the x and y-intercept. Remember that the x-intercept is a point on the x-axis, and the y-intercept is a point on the y-axis. So let's start with the first equation, which is x plus 2y equals 2. And we're going to find the x-intercept, then the y-intercept. So the x-intercept, you're going to set the y equal to 0. So you're going to have x plus 2 times 0 equals 2. And then 2 times 0 is 0, which means x equals 2. So this is your x-intercept. And then for your y-intercept, you're going to set x equal to 0 and solve for y. So you're going to have 0 plus 2y equals 2. So now you have 2y equals 2. And then divide both sides by 2. And you'll have y equals 1. So the x-intercept is 2 and the y-intercept is 1. So come over to the x-axis and put a point where you see 2. And then on the y-axis, put a point where you see 1. Then connect your points to make your line. Now let's graph the second equation. And again, we're going to use the x and y intercepts. So now we have x minus y equals 2. And we'll start with the x-intercept. So we set y equal to 0, and we'll have x minus 0 equals 2, which means x equals 2. And then the y-intercept, we'll have 0 minus y equals 2, which means negative y equals 2. Divide both sides by negative 1. And we have y equals negative 2. So now let's put a point where x is 2 and y is negative 2. And then let's connect our points to make a line. Now we need to determine where do they intersect at. So this right here would be the solution. And this is the point 2, 0. So the solution of this system is 2, 0. Now let's go ahead and do step 4, which was we're going to take the point and plug it into both equations to make sure that the left side equals the right side. So let's do it up here. So we'll call this the check. So it's going to be 2 plus 2 times 0, and the question is, does this equal 2? So this 2 plus 0, this is 2, so it works in the first equation. And let's check it for the second, and that would be 2 minus 0. Does this equal 2? Well, 2 minus 0 is 2, and 2 equals 2, so it works. Therefore, we can say, yes, this is our solution. Let's look at number 23. And we have the system y equals negative 2x plus 3. And y equals negative x plus 1. And we're going to graph each line. This time each equation is in the form y equals mx plus b. So we're going to use the slope and the y-intercept. Recall that you start by graphing the y-intercept, and the y-intercept is b, which is a number hanging out by himself. And then you're going to use the slope to graph another point. So let's start with the first equation, and we have y equals negative 2x plus 3. And we're going to start by identifying the y-intercept, which is a number by himself. So that's 3. So let's go and put a point on the y-axis at 3, which is here. Then let's go ahead and identify the slope, which is a number attached to x, and that's negative 2 over positive 1. So the negative 2 up top tells us to go down 2, and then on the 1 on the bottom means go right 1. So starting at the y-intercept, let's go down 2 and then right 1. So down 2, right 1, and then put a point. Now let's connect our points to make a line. Now let's graph the second equation. And we have y equals negative x plus 1. And again, let's use the slope-intercept form. So let's identify the y-intercept, and it's 1. So let's go ahead and go to the y-axis and put a point where we see 1. Now let's identify the slope, and the slope this time is negative 1 over positive 1. So the negative 1 up top means go down 1. And the positive 1 on the bottom means go right 1. So starting at the y-intercept, let's go down 1 and then right 1. So down and then right, and let's put a point. Now let's go ahead and connect our points. Now let's determine where our two lines intersect at, and they intersect here. So this will be our solution, and this looks to be 2 comma negative 1. So this is 2 comma negative 1. Now before we can say this is our solution, let's go ahead and check it to verify. So let's start the first equation. Y is negative 1, so we're going to say negative 1, and then put a question mark over the equal sign, and then we have negative 2 times 2 plus 3. Well, negative 2 times 2 is negative 4 plus 3, which is negative 1. So it works for the first equation. And let's check it for the second. So now we're going to have negative 1. And then we're going to have negative times 2 plus 1. So negative and then 2 plus 1. So negative 2 plus 1 is negative 1, which is equal to negative 1. So it works for the second equation. So we can say, yes, this is our solution. Now we're in objective 3, so we're going to be using graphing to identify systems with no solution or infinitely many solutions. There are 3 types of solution. The first one is exactly one solution, so the problems that we had prior gave us one solution. And when we graph these lines, they intersected at one point. The second type is no solution. So if we were to graph a system of equations and they had no solutions, then the lines would be parallel because they do not intersect at all. and then infinitely many solutions. This time when we graph the lines, they actually lay on top of each other, meaning they are identical. So they intersect an infinite number of times. So we will say the solution is infinitely many. So again, let's go in our books to page 285, and let's start by looking at problem number 29. The instructions are still solve each system by graphing. And in 29, we have the system x minus 2y equals 4. And 2x minus 4y equals 8. And we're going to graph each line. Let's start with the first line, and it's x minus 2y equals 4. This is in the form ax plus by equals c, so let's use the x and y intercepts. So the x-intercept, remember, set y equal to 0, so we have x minus 2 times 0 equals 4, which means x equals 4. And then the y-intercept, now we have 0 minus 2y equals 4. So negative 2y equals 4. Divide both sides by negative 2. And we have y equals negative 2. Now let's put a point on the x-axis at 4. And a point on the y-axis at negative 2. And then let's connect our points to make a line. Now let's graph the second equation. And we have 2x minus 4y equals 8. And again, let's use the x and y intercepts. So the x-intercept, and that's going to be 2x minus 4 times 0 equals 8, which means 2x equals 8. And then we'll divide both sides by 2. And we get x equals 4. And then let's go ahead and find the y-intercept. And now we have 2 times 0 minus 4y equals 8. So now we have negative 4y equals 8. Divide both sides by negative 4. And divide by negative 4. And we'll have y equals negative 2. So now notice that the x-intercepts for both equations are equal. The y-intercepts for both equations are equal. Therefore, if we were to graph the second equation, it would actually fall on the same line. Therefore, the solution to this system is infinitely many. Now let's look at number 36. And now we have the system 2x minus y equals 0. And y equals 2x. Let's start by graphing the first equation. It's in the form ax plus by equals c, so let's go ahead and find the x and y intercepts. The x-intercept is going to be 2x minus 0 equals 0, which means 2x equals 0. Divide both sides by 2, and we get x equals 0. And then the y-intercept is going to be 2 times 0 minus y equals 0. So negative y equals 0. Divide both sides by negative 1. And we get y equals 0. So the x and y-intercept is at the same point, which is the origin, so 0. Now, in order to make a line, we need another point. So let's go ahead and choose an x, plug it in for x, and then solve for y. So for your additional point, let's say we let x equal 1. So we're going to plug it in. So we're going to have 2 times 1 minus y equals 0. So now I'm going to move this up over here, which means we're going to have 2 minus y equals 0. I'm going to go ahead and add y to both sides. And we end up with y equals 2. So the other point would be 1, 2. So let's plot the 1, 2. Now we have 2 points, so let's connect them to make a line. And let's graph the second equation. This time is in the form y equals mx plus b, so let's use the slope and the y-intercept. So we have y equals 2x. I'm going to go ahead and say plus 0, which means the y-intercept is 0. So let's put a point at 0. And then the slope is equal to 2 over positive 1. So the 2 up top means go up 2. And the 1 on the bottom means go right 1. So starting at the y-intercept, let's go up 2 and then right 1. And again, we see that we fall on the same line. So the solution should be infinitely many. And then let's do the last one, which is number 40. And now we have x equals 3 and x equals negative 2. And let's graph this system. So we're going to start by graphing x equals 3. This time, this is a vertical line, and it goes through the x-axis at 3. So if you wanted to, you can put a point where x is 3. Then pick another point, but make sure that you keep x to be 3. Y can be anything. So I can put a point here, and we're going to connect. And this is the vertical line, x equals 3. Now let's graph the second, which is x equals negative 2. Again, this is a vertical line going through the x-axis at negative 2. So let's put a point where x is negative 2. And you can put one above or below, doesn't matter, as long as you keep it under the negative 2, and y can be anything. Okay, so now let's connect our points. This time we see that our equations or our lines never intersect. Therefore, the solution would be no solution. Okay, so this will conclude our video for chapter 4.1. Please email me if you have any questions.